So I'm going to use that idea right now. So I'm going to take this and rewrite it like this, like what you just said. Isn't that still a plus? So now I'm going to use this formula. So the first one is cosine theta. This one is this second one without the minus. You don't worry about it. So it's negative beta plus sine of alpha, the first one. And then I'm supposed to use the second one, so sine of negative beta. Do you agree? I use that formula? Just I have a first and I have a second. I have a first and a second. When it's a minus for the cosine, it's a plus in the formula. So now, this has to do with even and odd functions. Do you remember out of the 6 trig functions, which 2 were even? Cosine and secant. So when I put in my negative x, it's the same as the original function. So this is the same as the original. But sine of negative b, that's an odd function. It is the same as negative sine of beta. So it changes that sign, right? So this is equal to this. That's why there's no sign change. But this is an odd function. So it's the opposite of the original. The opposite of the original. So the negative gets out front, right? It's negative times this. So this is the formula for plus. It looks the same, except the plus has the minus has the plus. Other than that, it's all identical, correct? You have to commit these to memory too. These have to be committed to memory. Well, I've done 2 of them so far. We have 4 more to go. We're going to do sine next. I'm now going to do sine of alpha plus beta. And how I'm going to do that is I'm going to use these cosines. I'm actually going to use the first one. So I want you to think about this for just a minute before you look at this. So let's say it's sine of 30 degrees. Sine of 30 degrees, we'll call that 1 over 2. My numbers are going to be bad, okay? I'm not trying to make numbers that actually work. I'm just putting numbers. So sine of 30 degrees would be 1 over 2, correct? Give me another one that is equal to 1 over 2. Give me something else that's equal to 1 over 2 out of that triangle. Cosine of 60 degrees. Do you agree? Okay. So this would be 90 minus 30. The other one, 60, right? So sine of 30 is this over this, or cosine of 60, it's adjacent over hypotenuse. This is what I did. This is exactly what I did here, except I talked about it in terms of radians. Instead of 90 degrees, I thought of, isn't 90 degrees pi over 2? So let's pretend this is 30 degrees. This would be equal to cosine of 90 degrees minus this 30, right? Does that make sense? This is like a 90. So pretend this is 30 degrees. If this is sine of 30, then this should be the same as cosine of 60. How do you get 60? 90 minus that 30. 90 is pi over 2. Ask me a question if you don't see that. Again, I'm just doing the proof. Out of here. Okay, so now let me continue that idea. Let me turn that paper around. All right, so what I'm going to do to continue this proof is I'm going to distribute the negative, and I want to gather a couple other things together besides these 2. So that's a negative alpha, a negative beta, but I decided to put the parentheses around the first 2, and you'll see why, so I can finish this proof. I'm allowed to do that. I'm allowed to distribute the negative and scoop up 2 things with parentheses. That's not an issue. Now, what am I using again? I guess I better scoot it down. I'm going to use this kind. There's cosine, there's a minus, there's a first, and there's a second. A first and a second. So I'm going to use this right here. And so wherever I see an alpha, I'm going to put this. Wherever I see a beta, well, I'm going to put the beta. So that's what I did. And I'll show you why I did that. So I just use the first one because it's a minus. Again, I too don't see it very easily when you have symbols. I input numbers. It helps me understand what I'm doing. Now I'm going to try to clean this up. Okay, that's okay, and that's okay. I got to figure out how to do that. So I'm going to change that because I'm still more familiar with degrees. I'm going to think of this as 90 degrees. I'm just going to call this some other degrees. So cosine of 90 minus 15, I'm just going to write that out. Let's say it said 90 degrees minus 15. In other words, cosine of what? 75 degrees. What would that be the same as? Sine of 15 degrees, right? Or in other words, sine of alpha. And what is sine of, again, I'll call that 90 degrees. What was my alpha? 15? Would be the same as cosine of what? Of 15 degrees, right? Because that's 75. Right? Sine of 75 is the same as cosine of 15. So you mean it's just that? Like 90 minus 15, which is 75. So cosine of 75 is sine of 15. Oh, that was the 15. Sine of 90 degrees minus 15. In other words, sine of 75 is the same as cosine of 15, right? So I'm doing a proof. I'm doing kind of like verify identities. I'm replacing it with legal things. But now I'm done. So let's see. Cosine with a minus, cosine with a plus. They are very similar to each other, except the minus has the plus has a minus. Both cosines, both sines. Sine is different. This is a plus, this has a plus. It has a sine cosine, and it has a sine and a cosine. On the first side is alpha beta over here, then it switches. The sine is an alpha, then the sine has a beta. The cosine has a beta, the cosine has an alpha. I mean, you have to figure out, I'm just showing you out some things so you can figure out how to start memorizing these. The last one I'm going to do right now, I'm going to save tangent for later. I'm going to do sine of alpha minus beta, and I'm going to use this one. Oops, I need a clean sheet of paper. So to do this one, I'm going to change it to addition. I can do that. And then I can just go ahead and put that in there, right into this. The alpha is the first position, so that'll go here and here, and the beta or negative beta is the second position. So sine of alpha, cosine of the second one, which is negative beta, plus cosine of alpha and sine of negative beta. That's the second one. Then you have to remember, you have to remember even and odd functions again. You told me that cosine and secant were even. So when I put in a negative x, it comes out as cosine of beta. But this one here, it's odd, so it has to be positive times the negative. So this one doesn't have a signs change because he's even. He's odd. It's the negative, the opposite of the original. And I'm done with this one. So we have 4 of these. So sine of alpha minus beta, the minuses match, the signs match on sine. They don't match on cosine. Yes, ma'am? It's because when we studied even and odd functions a few weeks ago, probably somewhere in November, that we discovered when we put in a negative x, it comes out the same as this. And then we noticed it was also its counterpart, the 1 over cosine. But when you put it into the other ones, it is the same as the opposite of the original. Okay? So cosine and secant were the only ones that were even. And then I wrote on here that is in your textbook in the blue box, these four on page 583. That way they're all in one location. This one doesn't matter as much because it's positive. You know, negative order matters. So you have to know sine on this one here gets the first one. Cosine gets the second, minus, and then you just switch them out. Order matters. You can't put that front. That would be a totally different problem. So now, let's use the sum and difference formulas to do some different kinds of problems. And then we're going to verify identities. So for example, why do I need to know sum and difference formulas? It's because, like a problem right here, cosine of 15 degrees. Do you know cosine of 15 degrees without a calculator? I don't. I know, let's see, what do I know? I know cosine of 30. I could do cosine of 45. I could do cosine of 60. And I'm going to stop there because then they just start repeating themselves. And so with those numbers, can you make a 15 by adding or subtracting these numbers that we do know? What do you want me to do? Which two numbers? 45 and 30? And I would subtract those two, right? Or I could choose 60 and 45, and I could subtract those two. I don't see by adding anything would I get a 15, right? So let's just pick the two smallest, 45 and 30. So I could write this 15 degrees as 45 degrees minus 30. Do you agree? Now I'm going to use the difference formula, the very first one in your notes. So let's see, what was that? Cosine of the first times cosine of the second. The signs did not match. Sine of the first and times sine of the second, right? And I know all four of those. I can answer now cosine of 15 degrees without a calculator. Again, I'm going to get myself set up. This is multiplication, right? This times this plus this times this. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees, the tall one, is 1/2. Sine of 45 degrees is square root of 2 over 2. I have to make sure I know what quadrant I'm in. All of these are quadrant 1, so they're all positive. That's nice. And then sine of 30, oh, I did that wrong. Oh, no, that's right. No, I did that wrong. 30 degrees is the little one. I'm still brain dead. And now I just have to clean this up because I've got another problem here. I'm going to go ahead and go this way. Looks like my common denominator is going to be what? No, careful. 4, right? 2 times 2 is 4 plus a denominator of 4. So I'm going to write a 4. I'm going to gather this numerator. Square root of 2 times square root of 3 is square root of 6. Put down my plus. Square root of 2 times square root of 1. And I cannot add those together. That is my done answer. That is cosine of 15 degrees. I will leave it there. Please ask me anything. Ask me anything. Yes.
I have trouble understanding what you went over.
What's that?
I still have trouble understanding what you went over before the problem, like deriving and.
Do you understand what I did here?
I understand why, but I don't understand how it's implemented. Like I understand that.
Do you understand from here to here?
Yeah, that is because you're trying to.
Well, I don't know. I don't know that without a calculator. I can rewrite it with two sets of numbers that I do know, but I don't know how to write this until today's notes. I know how to write this. That's what's that. It's the sum or difference formulas of trig identities. And so then it's the alpha and the beta. alpha, beta, alpha, you just have to know that formula. And then you just have to know how to do, I mean, it's literally how to use today's notes.
Yeah, it's because I don't understand the part before that.
Which part is before that?
Formulas.
I don't understand that statement.
Like, what you just showed me before the problem.
So you mean the
alpha,
previous
beta,
page of
yeah.
notes? What don't you understand?
Like, I'm just having trouble putting it all together.
Well, this first one, cosine of alpha minus beta, I just gave it to you. Remember? I didn't derive anything. I just gave it to you. So this one, if anything, should be the least amount of issues.
Yeah, that was the very first one, right?
Right, I just gave it to you. So all the rest, all I did was show you proofs. You don't need to know the proofs. I just wanted to prove to you these were not plucked out of the air and I made them up. So all you need to know is those four. Yes, ma'am?
So these are going back to the unit circle?
Yes, always. We're in trig. We haven't left trig at all. Whenever you start seeing trig words, unit circle's alive and well. Ask me anything else. Let's try another one of these. Except now instead of degrees, I'm going to choose it with radians. Makes it more difficult. Sine of 5 pi over 12. Do we know that from the unit circle? I don't. I know pi over 6 and pi over 3 and pi over 4 and pi over 2 and 2 pi over 3 and 3 pi over 4. Unfortunately, probably most of it will be tomorrow and very little today, even though we got through a lot today.